Alright, these problems are actually given, the answers are actually given in lecture 23 solubility, uh, but maybe you might need an explanation, who knows. Anyways, I'm just gonna do this for myself. If you benefit from it, good for you. Anyway, alright, let's begin. So the solubility of calcium sulfate is 0.67 grams per liter. So in general, if you want you want to calculate first the molar solubility of this, right? Right now you only have, oh god, I hate myself. Right now you only have okay, so this is the solubility, right? Solubility solubility is in grams per liter, right? Molar solubility is in volume, and I've guessed it, moles per liter. So how can we convert this into moles per liter? Well, first of all, you have to know what calcium sulfate is, and in general, during a exam, you'll be given it, hopefully at least. So calcium sulfate is just CaSO4, right? You can calculate the mass of Ca, you can calculate the mass of sulfate, and you can calculate the mass of 4 oxygen atoms. You add them all up together, and you get a value of 136.14 grams per mole. So you have 0.67 grams per liter. So you want to get rid of the gram. So you can write it as 136, right? You can multiply it by 136.14. 136.14 grams per 1 mole. Right, this way the grams cancel out and you're left with moles over liters, which is exactly what you want. Enter this in the calculator. You have 0.67 divided by 136.14, and you'll get a value of 0.0049 moles per liter. But I'm just going to leave it at moles. So what's the KSP value? So the KSP value is essentially, okay, so this is a solid, and this dissociates into a calcium ion. Whoa, calcium. Okay, so there's definitely something going on with the charge. I don't know what. Oh, right, no. This is fine, right? This is an aqueous, and SO4 is a polyatomic ion, so it just has a negative charge there. Right, so that's a plus sign, and this is also aqueous. So in general, solids do not show up in KSP calculations, right? Solids do not show up. So, KSP is equal to the concentration of Ca plus and the concentration of SO4 minus. Well, this is a 1-to-1 mole ratio, so right? So the exponents on top are also 1-to-1. We didn't include it, but they're 1-to-1. And these are also 1-to-1. So this means that I have 0.0049 moles of this and 0.0049 moles of sulfate. So you would just plug it in, right? You just plug in 0.0049 times 0.0049. So that's just 0.0049 squared. And the KSP value is 2.401 times 10 to the negative 5. Well, ain't that freaking easy? It's pretty freaking easy, I'd say so. Alright, let's try a different problem. Okay, now this time we're given the KSP value. I don't know what copper 2 hydroxide is, but I'm assuming it's just CuOH. Just gonna Google it real quick. Copper 2 hydroxide. Yeah, CuOH2 though. Alright, this is actually a pretty new problem. CuOH2. right? It's U. So this is dissociates into Cu 2 plus, and we're going to get 2OH minus, right? Because there's a 2 here. Makes sense, right? Here's a 2 plus charge, so you need 2 negative charges in order to cancel out to make 0. Oops. Alright, well, in any case, we know what is the mole solubility. So we're given a KSP value. How exactly would I go about solving this? I don't quite remember, but let me see. Huh. Okay, so remember that this is a solid, and these are both aqueous. And in general, solids don't show up in the ice table. Ice. So we have 0 of this, and we have 0 of this, right? So this goes in the forward direction because there's no concentration of this and no concentration of this, and there's some concentration of copper 2 hydroxide, right? We don't actually care what it is though, because we're given a KSP value. I mean, we don't care what it is because it doesn't show up in the overall solubility equation. And we know this is plus x because it's going forward reaction, right? There's a 2 here, so this is plus 2x, and the overall equation is x and 2x. So we can, KSP is equal to the concentration of Cu2 plus OH minus, right? There's a, to the second power, because there's a 2 here. It's a common mistake people make. Don't forget it. So now we can plug it in, right? We can plug in, so we're given the KSP value, it's 2.2 times 10 to the negative 20 equals to the copper, which is x, and hydroxide, which is 2x squared, right? Squared, makes sense? Anyways, so 2 to the second power is just 4, x to the second power is just x squared, right? And this is multiplied by x, which is essentially just 4x cubed. I'm going to rewrite everything up here, right? 4x cubed is equal to 2.2 times 10 to the negative 20. Divide 4 on both sides. X cubed equals 2.2 times 10 to the negative 20 divided by 4. And then you just cube root it, cube root both sides. And you get x is equal to whatever this value is. 0.2 times 10 to the negative 20 over 4. The value turns out to be, x actually turns out to be 1.8 times 10 to the negative 7. This is an 8. Okay, so this in itself is the mole solubility, right? This is moles per liters. This is the mole solubility. Now let's say I want to calculate the solubility. You know, so we have the mole solubility, which is 1.8 times 10 to the negative 7 moles per liter, right? Earlier we said solubility is grams per liters. So how do we turn this into grams? Well, you know, so you have copper hydroxide, right? So Cu is some mass, OH2, OH is some mass, you multiply that by 2, so 2 times some mass. And the molar mass of this is 97.561 grams per mole. I don't want to actually calculate it, but I'm pretty sure you know how to do it if you're at this level of chemistry. So the moles per liter, we want to cancel out moles. So what we can do is 1.8 times 10 to the negative 7 moles per liter. Multiply that by 97.561. Oh, no. Yeah. Grams per mole, right? Grams per mole. Moles cancel out, you're left with grams per liters, right? You multiply this value straight through, and you get solubility, and that will be your answer. Have a great day for me and you.